Let's begin with a common object, a chair. If I showed you this chair, we would both immediately agree that it is a chair. Now let's assume by atomic theory that it has n atoms. Now I remove a single atom and I ask you, is it still a chair? You would most likely say yes. And now I remove another and another and another atom. I keep removing one atom at a time and I ask you at every single step, is it still a chair? If you insist on saying yes at every single step, you're eventually left with zero atoms. Yet you are forced to conclude that the zero atoms constitute a chair. This is a clear absurdity. This is a contradiction. The chair cannot both be existing and not existing simultaneously. But let's say you choose to say no at some specific point, let's say an arbitrary 50% mark, then you would be asserting that the removal of just one atom, that is, let's say the 51th percent of the atom, fundamentally changed the object's identity. That is, it ceased to be a chair. But why did that one atom make the difference? When the atom removed just before and the atom removed just after did not, then that means you'd be asserting uh, the whole uh, identity of the chair to just one atom, which seems very arbitrary. So the point is that choosing a cutoff point seems entirely arbitrary. Now, what assumption is causing this collapse in logic? We'll have to realize that it's not the atomic theory itself. The real problem is our second assumption, that we can all agree on what a chair is. The chair is what the philosophers call a vague predicate. It lacks a precise objective boundary. Most people might agree on this comfortable for traditional object being a chair, but they will likely disagree in this highly abstract avant-garde piece of furniture. The chair is not a physical object, it's an abstract concept we use to categorize physical objects. This is very similar to how an AI model learns. When we are deciding if an object is chair, we are not consulting a dictionary. That is, we don't have a standard to look up to. Like, let's say there's no the chair that we can look up to, and then by comparing our chair to that chair, if we can't make judgments about any other chair. What we are doing is we are consulting our internal model, which is a massive data set of past experiences. We look for similarities, uh, which could be a seat, a bag, four legs, anything that with the chairs we have seen and been told about since childhood. This is exactly how a machine learning model is trained, a process called supervised learning. The first step of which is training data. The model is fed with millions of images that are its training data, each one labeled either a chair or not a chair. That is the ground truth. So this first step, this has also happened in our childhood. That let's say we've done something and we receive a feedback loop from our parents, our neighboring, our surrounding people, that what we have done, if this is this thing is what we all collectively agree on it to be or not. So it's always a binary response in the sense that either what you have done is socially all is all socially we all are on the same page about it or not. For instance, if I miscorrectly point towards a table and say that this is a chair, I'll get a negative feedback about I'll get a negative feedback saying that this is not a chair, and then my internal parameters will be again updated based on their responses, which is exactly what happens in AI models. The second step called reinforcement. The model makes a guess. If it's correct, it gets positive reinforcement that is its internal parameters are adjusted to favor that guess, and if it's wrong, it gets corrected and its parameters are adjusted away from the mistake. And the final step is then generalization, in the sense that eventually the model learns to generalize. It can classify a chair it has never seen before by finding patterns and features, like legs and back support, common to its training examples, which is also what we do in our case. For instance, since childhood, we have been told what exactly is a grass and what is not. Let's say there are flowers in our backyard. So your parents will tell you you'll go up to them and ask them what this is, and they'll tell you that these are flowers, and then you'll go to your school and then ask your teacher what those are, and they'll say you that these are flowers, and then you're on a vacation with your parents, and then you'll notice something similar, an object having colorful petals and and having leaves and is inanimate. And then you'll recognize that these are all the patterns and features that you have seen before, which resembles like a flower. So you'll conclude that this must also be a flower. So what's happening here is crucially different people have different training data. Our individual model of chairness are shaped by the furniture in our childhood home, the language spoken by our parents, and the culture we grew up in. And not just the model of chairness, the model for anything in general. It's shaped by the narratives of our parents and anything that we have been influenced by in our childhood. This is exactly the source of inconsistency in our opinions. If your training data contains many different types of seating, you might accept a wider ranges of objects as chair than someone whose training data is very narrow. So the paradox teaches us that the existence of object is not absolute. Of any object is not absolute. It is a function of our socially learned approximate definition. A chair is real only because of our collective, reinforced, and somewhat vague mental models agree that this is.